Hey everyone, imagine being a software developer where your clock is ticking and you're racing against the time to make sure everything is working perfectly. Now, what if I told you there's an easier way to make sure everything is running smoothly? Yes, shift left testing. That is what we are here to talk about today. I'm Rukaya Hilmi, an undergraduate student from Department of Computing in the University of Buckinghamshire. Alright, before we dive into the theoretical frameworks, let's have a quick peek at the roadmap of our journey today. I have categorized this presentation into three main sections. We're starting off with a big picture. In this section, I'll break down what shift left testing really means and why it matters in today's fast forward world. By the end of this section, you will have a solid understanding of why moving to the testing earlier in this process isn't just a good idea but is very essential. Once we've figured out what shift left testing really means, let's take a step back and think how we came back to this position of discovery. Why did this traditional method fail short? In this section, this is all about the comparison between the software testing. We will compare and analyze some traditional approaches like waterfall model along with the shift left testing models. I'm sure by the end of this section, you will be convinced why I'm recommending to use this approach. Finally, let's go into deep. What does this really look like in action? In this section, we'll get into more practical side of this. I'll show you how teams implement shift left testing and why it makes all difference in success so that you can break it down and think how to implement it into your projects. So let's begin. So what does shift left testing exactly mean? Let's break it down with an analogy. Imagine you're watching a movie and you're allowed to give a feedback only after the movie ends. If you spot out something wrong, maybe something doesn't make sense, or maybe something is very confusing, you're already too late to change anything. Now imagine if you could give the same feedback while a movie is being made. Making changes at that time scenes unfold. That's what shift left testing really does. Instead of waiting until the development process is done to catch the bugs, shift left testing helps you to find and detect the bugs in early stages of the development lifecycle. This approach lets us spot very small defects before it's too late to be detected. The earlier we catch the bug, the easier and the cheaper it is to be fixed. Think of it like this: fixing a tiny crack in your wall is much easier than waiting for it to become a huge hole. Do you think this approach came overnight? Well, the answer is no. The testing has come a long way. Originally, the testing was something you did at the end of the process, almost like a last minute check. But later on, the demand for continuous delivery kept on increasing exponentially. Following the same traditional approach led to many discomforts over the time. That's when we realized prevention is better than the detection. Fast feedback and collaborative development are crucial on prevention of defects. With the rise of Agile and DevOps, we saw a shift in testing. Agile made development faster and more collaborative, which led to the testing introduced in earlier stages of the life cycle. In waterfall approach, everything follows strict sequence. You gather the requirement first, then design your system, then code it, implement it, and finally you test it. The issue here is very simple. The testing happens at the end, which often results in finding the bugs too late. But by that time, fixing them can be very costly and time consuming. A V model is a bit more structured waterfall approach. Testing is done after development, but it's integrated into each phase of the development. However, it's still similar to the waterfall model. Then comes the agile model. Agile changed the game by introducing the short development lifecycle or sprints with testing integration from start. It promotes the collaboration between the developers and testers, which helps to catch the bugs early. But Agile doesn't go far enough. So then comes the DevOps pipeline. DevOps combines the development and operations into one continuous flow. It emphasizes on automation and collaboration, making it impossible to test more frequently and earlier. This makes shift left testing even more important as it aligns perfectly with the DevOps principle of continuous integration. The shift left testing is a practice of moving the testing into the early stages of the development lifecycle. By catching bugs and issues sooner, the teams can reduce the cost and improve the quality. The key idea here is not about making too many testings, it's about making a smart testing. Comparison of testing traditional testing approach with the shift left approach. In traditional models like waterfall, as we discussed earlier, I have done so many researches and I have given you everything summarized into a chart. As we discussed earlier, it's very clear the testing begins only after the development in the waterfall model, while it starts during the planning itself in the shift left model. The feedback is very slow in the waterfall model, while it's very fast and continuous in the agile model. Bug detection is late in the waterfall model and very early and frequent in the agile model. Collaboration level and change of adaptability is very low in the waterfall model, but it's very high in the shift left model. Risk of late defect is very high in the waterfall model, while it's very low in the agile model. Here's something that's really going to put things into the perspective. The cost of fixing bug isn't same at every stage. Think of things like this. If you find a small leak while building a boat, it's easy to patch up. But if you notice the same defect after you set it to sail, it can sink and ruin the entire thing. This chart shows that fixing a bug during the requirement or design phase is relatively cheap and straightforward. But if the same bug is caught after the production or release, it could cost lots of loss, thousands of dollars, or even damage the entire company's reputation. That's where shift left testing becomes so powerful. By moving the testing in earlier stages, we can catch bugs in earlier stages and reduce the budget drastically. We have discussed so many benefits so far throughout this presentation. I have summarized all those benefits into one slide for your view at once. Shift left testing gives you uh, a cost efficient model and it's early to detect the defects. Fast time to the market, improved collaboration, enhanced productivity, and quality, better test coverage. Let's talk about the tools because shift left testing is not just a mindset, it needs the right techniques to make it work. We have tools like Jenkins, which helps you to automate the and build the testing process. This is essential for the continuous integration. Selenium allows you to automate browser-based testing, so we can test user interface without clicking throughout manually. A Postman can help us to test API quickly and effectively, which is super helpful in today's cloud and microserver environments. These tools and many other tools lets us test early and test often and test automatically. They, they are going to reduce a huge weight from the backbone of the testing team. While I was studying about this shift left testing approach, I really made a case study on a real incident. Let me share you a real world story that clarifies my idea. In 2012, Knight Capital Group, a major trading firm in US, rolled out a new software technology to their live trading system. But they missed a very serious bug during the deployment. Why? Because not outdated code was removed. And worse was there was no proper testing done before pushing it to the production. As a result, within 45 minutes of release, they lost a shockingly $440 million, and the company has never fully recovered yet. This disaster happened because of the complex issue and also because of a small bug which was caught too late. They had to test the software early or even use an automation tool as a part of shift left approach. And in that case, they could have been identified before it went to live. This case is so powerful reminder that cost of late testing isn't just about money. It can destroy an entire company's reputation. Now let's take a look at the opposite side, a successful story. This shows why the shift left testing is really important. Microsoft Azure DevOps is a cloud-based toolset used by the development teams all over the world. Microsoft wanted to speed up releases and reduce the bugs, so they adapted to shift left testing as a core part of their development process. Instead of waiting for the test to end, Microsoft Teams write and runs the test from the very beginning of each sprint. They use automation testing, CI/CD pipelines, and continuous feedback loops to make sure everything is checked early and often. The result was higher in product and quality, faster delivery cycles, and fewer production bugs. And they've managed to maintain this level of quality even while releasing the updates multiple times per day. This is an example that shows when company commits to early testing using the right tools and culture, they can build a better software faster with more confidence. This gives a really big value to the testing environment. In conclusion, shift left testing is essential for modern software development. By catching issues early, we can save time, reduce costs, and improve overall quality of our software. As we move forward, the faster development of cycles and more complex systems, shift left becomes not just a strategy but a necessity. Let's have a quick recap with a small quiz to check if we have understood everything. Pause the video and take your time and answer these questions. I'll discuss it from my end. Fixing a defect in a production is more expensive than fixing it during the design phase. That is true. Agile and DevOps support continuous testing, which aligns with the shift left principles. That is true too. Shift left testing means delaying testing until the software is fully developed. That is false. Shift left testing reduces collaboration between the developers and testers. That is true. Okay, I'll reveal the answers. Yes, we have done it correctly. In case if you still have any doubts, here are the references I used throughout this presentation. If you're curious to learn more about these topics we discussed, these are the really great resources for you to start up with. So I'm winding up this presentation here today. Thank you for your time. Have a nice day.